Today we will discuss the data processing and how to handle the data when you are getting it. First of all, we need to read the data, then we need to clean the data. Clean from what? Clean, this is when we are getting the data, we need to understand if there is duplicates, if there is missing data, if there is columns we don't need. This is all we calling cleaning the messy data. Then we need to check if there is any problem with the formats we need to do. After that, we will see if we have some features we don't need and have some features we need. Then we will eliminate unwanted data to make our model fast. So what is the data we have? What is the types? We have two types. We have categorical data and we have numerical data. Categorical data, usually we are saying this is a categorical data when we cannot count and we cannot make any mathematical functions on it. It's qualitative data. Unstructured, it's qualitative data, not quantitative data. For example, student, green. We cannot say, for example, green is better than red. Male is better than female. Both are in the same weight for the model. Categorical data have two types of data. Ordinal data, which we can say it's ranked. For example, young, adult. So young is different than adult. We can say junior, senior, manager. We can rank them in different levels. They have levels. This is ordinal data. Another type of data which is nominal data, which we cannot make it ranked. For example, cat and pencil. No any rank for them. This is categorical data. Back again to numerical data, which is quantitative and we can do mathematical data on it. So for example, we can say the height of someone, 180 cm. We can say the weight of someone, 80 kilogram. The price of something, hundreds of thousands. This is all quantitative data and we can make mathematical data. Why we are making all of this? Because all of them have different way of handling. Our model cannot understand categorical data, so we need to encode our categorical data to give it some labels and make it numerical labels, so our model can understand what is this. In the other way, we will handle the numerical data with scaling. This is different thing. So how now to handle the missing data? Our missing data have a lot of ways to handle and that depend on the situation and the quantity of data. For example, if I have a huge quantity of data and I have very minor 0.5%, for example, some missing data, and I don't care about them, or they are not crucial, or they will not affect my model, so I can easily delete them. But normally we are trying to avoid deleting or dropping any missing data and try to find another way to give me near data and with some error, which will not affect me a lot. And this we will see when we are making our model. We have a lot of techniques, and these techniques depend on if it's numerical data or categorical data, and this is we will all explain it. For example, to get the mean or the mode or the median, to get the nearest k variable, or to make a regression of for example, this variable have a lot of relationships, so I will make a relationship regression model to find what is approximately will be this model. And we will discuss in our course these techniques, which is the normal techniques. We will not discuss the advanced techniques, multiple imputation, deep learning approaches, domain-specific algorithms. We will not go through them. So let's know some expressions we will use. For example, what is the mean? Mean is normally is the average of my data, but this is only in the case of symmetrical distribution. Also, I can use mode, which is the most frequent value, and this is we can use in categorical data, and this is I can find many modes in the same time. Median is the average when I have skewed data. Going to our data, we are making distribution to our data 25%, 0, 25%, 50%, 75%, 100%. This is our data. We have something called the box plot. Box plot, we are seeing how far is our data to the normal distribution. And we will find an expression coming here. It's called outliers. Outliers is have this equation as you see. Outliers is some data which going far away from our acceptable values. And IQR, which is interquartile range, this is between Q1 and Q3. Back again to encoding. We told we will take the categorical data and make encode for it. There is some ways of encoding. For example, we will say label encoding. I will say red is 0, green is 1. This is label encoding. The other way it's called one-hot encoding and the label encoding. The label encoding, we are checking apple, it's 1, checking 2, broccoli 3. This is the label encoding. For one house encoding, we are make 1 on apple, right? And we are making zeros for the remaining variables. Chicken, when we are go to chicken, we will make 1 at the column of the chicken and we'll make zeros in the remaining columns. So we are making zeros in the other columns, which is not our columns. In one column, we will make 1. This is one hot encoding. The latest one is the k nearest neighbors, which will make an algorithm to make the relation between all the variables and give you assumption for the remaining one. It will be working for categorical and working for nominal also. Back again to numerical data and the scaling. In some points, we need to let we need to avoid to make the model to think that some items is very important and some items need to be neglected, which is the scaling. We have some items have a high value and some items have a low value. So he will give importance, the model will give importance to the high value. He will think this is very important variable and I need to give in my equation high importance to it. So currently we are making scaling, and scaling have many ways to make scaling, as you see, and we are preferring normalizing since you can give it the min and max value you want, so you can control it. So normally we are making between 0 and 1, so most of our data will be in between 0 and 1 by scale. In the end of our program or our model, we will download this scale with us and we will keep it with the model, so you can scale and reverse the scale after that. And this point we will check together when we go to the implementation, because we have a trick here to get back any ratio with our scale. Finally, we need to train and test our data. We will make a split to around 80% from our data to train our model with 80% only from our data, and 20% we will leave it for testing. He don't know anything about them. Then we will train our model with it. Then we need to evaluate our model if this accuracy is acceptable for me or not. If not, I need to change our way of training or our algorithm. Then we will retest it again. This is our steps quickly, and we will go from next session. We will go and make this on our model, and we will see each step in details how we will make. If you like this video and want to see more, please give me a like and subscribe. If you have any comment or you have any problem, please comment below. If you want to see the previous videos, please check the playlist. I have a Python playlist and I have this playlist for AI Python. Thank you for watching and see you next time.